Welcome to another Ocean Ideas Talk, brought to you by ocean lovers.
I'm delighted to welcome back the ABC's Natasha Mitchell to introduce and host our panel of experts and a fascinating discussion around how algae is the new gold. Please join me in welcoming Natasha.
Thank you so much, Robin. Yes, who was at the SharkNet session? Yeah, great. Thanks for sticking on. This is going to be fantastic, this conversation. I'm very excited about what these three people are involved in and what they're achieving. So if you've just joined us, of course, welcome to the Ocean Lovers Festival Talks program. I want to acknowledge the relationship that the Gadigal people of the Eora Nation have had with this beautiful coastline and this beautiful ocean along this coastline for over 60,000 years. My name is Natasha Mitchell. Yes, I'm from ABC Radio National. We're recording today's sessions for Big Ideas, which is a fantastic events-based Big Thinkers, Big Ideas show, all sorts of topics. You can find it on the ABC Listen app. We're here to talk about all things algae, macroalgae, microalgae, seaweed. You're about to meet three homegrown researchers and entrepreneurs who certainly think that algae is not just sexy right now, but the new gold. So I'll be interesting to find out why they think that and what they're up to. They think Australia is in a unique position to make a real go of the algae business. So what does the algae business look like? Why is algae the new gold? They think that it potentially holds some solutions for climate change, for cow farts, for beer brewing, for biofuels, for clothing, for fabrics, for a substitute for plastic, and a whole lot of health supplements and also food for non-human animals as well. We've got Michael Askew, who's an environmental systems practitioner, long career in various leadership roles. He is now executive director and co-founder of AlgaeCo. They produce high-yield microalgae for human health products, nature-based remediation for industrial sites, carbon emission reduction and more. And they've got projects in India, but I think they're also finalising their first Australian project, yeah?
Yeah, there'll be a project starting maybe July, hopefully. So it'll start next year.
Look forward to hearing more about that. We've got Dr. Pia Winberg, who's a marine systems ecologist specialising in macroalgae, seaweed. She's the founder and chief scientist of Venus Shell Systems. They're based on the New South Wales coast of New South Wales. I've spoken to Pia before, and what a story she has. She discovered and now cultivates and farms a unique Australian species of seaweed for a whole range of different uses, which you will hear about, but she's got a big vision for what seaweed can achieve for us environmentally as well. Thanks for being here, Pia. And we've got Dr. Alexandra Thomson, who's a marine ecologist who used to research the potential of our coastal systems to capture carbon, and certainly seaweed is part of that story. She's now the Industry Engagement Manager for the Climate Change Cluster Research Institute at UTS. And through what's called the Deep Green Biotech Hub at UTS, Alex spearheaded the world's first dedicated algae accelerator program to really get innovation happening. Let's give them a warm welcome. And it is a warm welcome. It's getting quite warm in here, isn't it? A question for you all. Why did you become interested in the possibilities of algae? Why algae? Michael?
We were in universities working in the algae space, working with colleagues, evolving new species. We knew the industry had a lot of potential, and we knew a lot of players, big microalgae cultivation companies that had sort of gone under. Then suddenly the world discovered plant-based, algae-based omega-3s and other vitamin D3, omega-7s, and carotenoids. So when you walk in, I remember getting off a plane, going into Bangkok and suddenly seeing on billboards mothers giving children algal oil, spoons of algal oil, walking through Emporium, a big fancy shopping centre, and all the skincare had omega-3, but it was all algae-based omega-3.
Yeah.
And it sort of clicked, okay, now it's ready. Now the industry's ready. So we stepped out into that space, and now we have a plant in India, another one in Australia, and another one planned for Western New South Wales.
Okay, interesting. What type of algae are you working with?
In microalgae, we've got 15 uniquely evolved species that my business partner, Dr. Swaminathan, developed over the last 18 years, and they're used in a range of different applications.
Okay, they develop them.
Yes, you have to evolve, and Pia knows better than anyone the time it takes to evolve these specialist species to handle different conditions.
Pia Winberg, what about you? How did you get into this world of seaweed and in such a passionate way?
Yeah, well, I didn't wake up one morning thinking I'd be a seaweed farmer. And I think it's just common sense, really. If you follow common sense, all things will lead to seaweed. And part of the reason is, I'll explain. And part of the reason is, seaweeds, algae are the foundation of the life on the planet that we live in today. The great oxygenation of the Earth. All of the biogeochemical cycles of carbon, nitrogen, oxygen around this planet were set up by seaweeds, and then plants are part of it now too, and now animals and humans. And that whole balanced system was originated with algae and seaweeds. And now, as humans, we've done our very best to disrupt that system. And so part of the solution is going to be to get algae involved in resetting the system again. So that's really my personal motivation. And then when you start to look at the seaweeds and algae, and my gosh, what they can do, the breadth of opportunity from the molecular level of them to large-scale materials that you could look at building with them, it's sort of the magic pudding mining resource of the future, in my view.
But at what point did you, when you were, as a marine biologist, you discovered a new species of seaweed, at what point did you go, I could actually farm this and look at its molecules, understand how to make it in a farm context, in an industrial context, and then utilise it?
Well, my first opportunity was now 25 years ago while I was at Stockholm University in Sweden, and I got to go to Sri Lanka to look at the devastation that aquaculture had created on this earth back then. It's just that they got the ecosystem wrong. They weren't reading the system and they stuffed it up. So the prawn farming in Sri Lanka was cutting down mangroves, basically plumbing the tiger prawn farm toilets to the kitchen sink and polluting themselves, killing themselves. The whole aquaculture industry has suffered just from not understanding and respecting the ecological systems that support it. And so I went to Sri Lanka and found a tiger prawn farm I did research on for my master's in '98, and seaweed was key. You know, you can turn ammonia into nitrate and it's not as toxic for the prawns, but you're actually not getting rid of it. And on that front, one of the biggest planetary boundaries we have crossed that people aren't paying attention to is nitrogen. That's what we are spreading out, whether you're a prawn or a person, from your foods, and it all lands up in the coastline, and it's killing the ocean systems. And that's really when I realised that seaweed is there to turn nitrogen around. That's my driver, and that's what I set out to do. And then I went, but hang on, no one pays to clean up this planet. We'll have to make something from it and sell the product instead. So that's the sort of journey I went on.
Interesting. We'll come back to what you're up to. Alex Thomson, what about you? Why algae?
Well, so when I was doing my PhD research, a lot of it was looking at coastal systems and the types of disruptors that are happening in those coastal systems that are stopping them from capturing carbon. I'm sure you can imagine over the last sort of 20 years particularly, there's been a lot of very sad stories about the loss of our ecosystems, how that's further pushing climate change. And to be honest, by the time I kind of finished my PhD, I was just like, well, nothing that we're doing is really making that big of an impact. I keep generating this data, hopefully sending it off somewhere so someone will read it and do something about it. But at the end of the day, there's not that many people that read research articles in the public. So the impact of that type of work is pretty minimal. When you look at opportunities like algae, you start to see that there's a way to reframe how we manage our biological systems that gives us climate hope. It starts to kind of look at things and go, there is this organism, if we turn our ecosystems around, if we change how we farm, this is a way that we can start to generate products that previously we were really relying on fossil sources from, and it starts to kind of go, all right, so there is some actual opportunities out there. And I think for a lot of people, particularly working in the climate space and the marine space, it's kind of a real area of opportunity.
Okay, so you've all spun algae really beautifully. I want to actually understand its potential even more deeply now. So, Michael Askew, what are you doing with algae? I'm really interested that you're using algae to mop up pollution in interesting ways. Talk about that.
Yeah, we've developed a species of microalgae that can handle really high salt environments. So we can go into power stations, desalination plants, and we can take their brine water and process it over a decade. And of course, we produce a lot of algae from that process. We then put that through our own processes, extract algal oil, which is generally sold on global markets for omega-3 as a fish oil replacement.
Yeah, right, I'll come to that. But sorry, how does algae mop up pollution? I know you can't give any secrets away here, but what's the basic science here?
It uses it for its own development. So it's using nutrient. In this case, we're using a halophilic species, which means salt-tolerant species, and it can use that salt for its own development.
In the way it does in the ocean.
In the way it does in the ocean, but we've evolved a species that can really handle extremely high salt concentrations.
And are you using it in industrial sites right now?
Yes, we're using it in India at the moment, and it's working phenomenally well. It's actually cheaper than traditional reverse osmosis filtration systems that people use for high salt. We can use algae, and we don't just dump the salt. We've got a product then that we can sell for human health or bioplastics or
so this is
whatever the
interesting.
final use.
You're feeding algae on industrial waste water,
Yes.
essentially, but then you're growing that algae into a product that could replace fish oil. Just describe the impact of fish oil and why that interests you.
Well, the global fish oil industry, everyone's well aware that the benefits of fish oil and the benefits of fish. But the only reason that fish have any benefit is because they eat microalgae. And those microalgae are full of things like omega-3. We then buy fish oil for omega-3 consumption. But most of the fish oil globally is sourced from Peruvian anchovette in the East Pacific. It's quite frightening. I don't know the actual percentage, but it's like 85%. Comes from Peruvian anchovette, and the devastation to the East Pacific is stark.
What sort of devastation?
Ecosystem collapse in that part of the Pacific, but they keep farming because fish oil demand's actually going through the roof.
Huge. Who takes fish oil in the audience? Yeah. Or who takes fish oil replacements? Not fish oil, but other products. Yeah.
Yeah. So where algae can step in now and stem that increase, there are enough algae producers now where we can see scale out to a level where we can stem the bleeding, basically, of the global fish oil industry, and then we'd love to see us slowly take a big chunk out of the fish oil industry, because algal oils they're not contaminated, high concentration, better quality product from algae, and you've got all these other benefits and no environmental destruction.
Yeah, that was the question I have for you. If you're taking wastewater and you're feeding algae wastewater from industrial processes, what about contaminants?
The title of this is Algae Gold. Algae literally is gold, not only as a product to sell now, but from an environmental systems perspective, from its cleanup potential, carbon sequestration, and the opportunities around learning. We have, at our plant in India, we have locals who are now going to be put through a university in microbiology, learning about this system and how it works. So we can build out these sort of social, environmental, human health aspects around algae, and the fish oil industry cannot do that.
Pia Winberg, you're involved in developing all sorts of products from seaweed as well. So talk about what you're up to. But I'm interested too that you are also taking a waste product to feed your seaweed. And just describe what the setup is there. You're not growing seaweed in the sea, are you? You're growing it inside big vats inside a factory, yeah?
We are doing an indoor system as well, but our big system at the moment is giant pools, basically. And so we are located next to one of the largest wheat refineries in the Southern Hemisphere. So who drives E10 fuel? If you've got a hybrid, maybe you put the E10 fuel in. So where the 10 is made, That's made from waste starch products that are taken down to Nowra, fermented, and the natural fermentation process produces carbon dioxide, like we breathe out carbon dioxide now. We catch that, but also when they're washing down all their big vats from the wheat and starch processing, it's like the washing water going down your sink. It's actually full of nutrients. And there's so much at this factory that they concentrate that and we recapture the nitrogen. And as I mentioned before, 50% of people that live on this earth today rely on a synthetic capture of nitrogen from the atmosphere in the northern hemisphere. So in the northern hemisphere, they're catching nitrogen out of the atmosphere because we don't have enough nitrogen in the soils to grow the food we need. That's shipped to Australia.
So as a fertiliser, you're talking about nitrogen as a fertiliser.
Yeah. So that's caught from the atmosphere. It's been doing that for 100 years for fertiliser and dynamite. But we bring that on ships to Australia. Then we're spreading that all over our wheat farms and all our produce farms. And then that nitrogen ultimately goes through us or our animals or the rose bed or the wheat field, and it all ends up in the coastal zone. So can you imagine? We've doubled the nitrogen flow from the atmosphere to the coast. Exactly, and so that is where the big pressure is to turn that nitrogen around. Now in Europe, people aren't so aware. In the Netherlands, farmers are walking off their farms because the government's telling them they can't farm anymore. There's too much nitrogen on the coast of the Netherlands.
So what are you doing with nitrogen and seaweed?
Well, nitrogen, ironically, is the foundation of protein and collagen and everything like that. So why aren't we using it? So that's what I do, is I catch it and I bring it back into a food system and turn it into both protein, but also the different seaweeds and algae. They are a rainbow of so many ingredients. It's a bit like saying, I'm a farmer, I grow plants. Well, if you're growing a pine forest, you're a farmer, and if you're growing blueberries, you're a farmer. But they're quite different products, and they've got quite different attributes. And the same in seaweed. So we've focused on a unique green one that we feel is an exciting new space to develop algae in. I don't want to, grow nori when Korea, China, and everyone else are doing it so well, or kombu when China and Japan are doing it so well. We're focusing on a unique green seaweed, and the polymers and the molecules coming out and the proteins coming out of this can actually work in a way where this should become a staple in food crops. So our pasta has 10% seaweed in it. It's replacing the wheat. So we're replacing big chunks of the food industry made on regenerated nutrients instead of that one-way flow of nitrogen from the atmosphere.
So what are you making? Because you're working on a whole range of different fronts, aren't you?
Yeah.
Supplements. I know that you've been working on possible seaweed-based wound repair. Based on your own experience of an injury actually on site in your factory, a wound repair product as well. And I just talk to that a bit and how you develop consistency, because if you're going to develop seaweed products, you need to land them in the market in a way that they're the same ingredients, they're consistent, they are what they say on the label. Is that hard?
Yes, and that when people say, I'll just go and start a seaweed farm now, you're just, okay, there's a lot of research behind getting that done. Just things like I mentioned, the protein, that can vary from batch to batch depending on how you grow it. And that's the opportunity we have in our controlled pool systems, is that we can deliver more consistent protein levels all the time. Because if you're selling a protein product, you want it to have the same protein in it. Yeah. So we know how we do that through cultivation. But also we have to know how different species have different ingredients. Like kombu is a great seaweed, but we can only eat a little bit of it because of the iodine levels, which can be dangerously high. And so people don't know, people are aware that seaweeds have got iodine in them, but they're not aware which ones. So we know which ones are safe. We also know when we process them, what molecules can we pull out. And the exciting thing about seaweeds for me actually is the gels. The whole world of seaweed gels and slime is a frontier of biological and medical research that we've only scratched the surface of, because gels are complex sugars. They are the code of life. And so we've actually now done 3D printed recreation of skin tissue in Petri dishes, and we're now working with Fiona Wood in Western Australia.
The amazing
to improve her
plastic surgeon on burns injuries.
That's right. So she can actually develop the skin spray and can now save lives, but the skin is not so functional. So we work on our seaweed gels creating functionality in those new grafts. And yeah, like you said, I could have used some of that myself. Careful what you wish for, hey?
Yeah, yeah. Well, you might know Pia's story. We won't go into the detail today, but you had an accident with being scalped on your work site, despite all precautions and all safety measures. So you're doing okay now?
Yep, got my seaweed cream. It's great.
Got her seaweed cream.
And we're on ABC, and Pia won't say, but her PsychoHealth sea fibre tablets are life-changing. So
no product
Those
placement
personal
on the
way,
ABC.
right?
Incredibly.
Well, I will come to Alex Thomson now, because I am interested in how you develop one, you've got to kind of Australia's got some real potential here, and that's a challenge. How do you make that happen at a scale that will be successful? But also, how do you develop a scientific evidence base? There are a lot of promises and claims made about, and I'll ask both of you this too, about seaweed-based products and opportunities. Do you have to cut through the spin with some good science?
I don't think that other people on the panel will mind me saying that Australia is probably 10 to 15 years behind all other global markets when it comes to algae and seaweed.
Why?
If you look at how we grow an algae market, there's a couple of really big expenses. The first one is the cost of cultivation, and the second one is obviously there's environmental concerns. We want to make sure that there's appropriate permitting and legislation in place, that sort of thing. So when we look at cultivation, if you're really wanting to make high value products, we're talking medicinal level, really high quality, you usually have to grow indoors. As everyone will know, our electricity costs are now through the roof. So if you're looking at things that require lighting and that sort of thing, it becomes quite expensive. You can go to outdoor systems, that becomes a bit cheaper. But then when we come to legislation, permitting side of things, I think most of the people here will understand that there is very little recognition of algae in the Australian government, both federal or state level. So it's starting to change a little bit, but it's quite tricky to do things like bring new algae species into Australia that have been successfully cultivated overseas.
Because of quarantine issues.
Because of quarantine issues, which of course are very valid issues. There's obviously big concerns with, can we start seaweed farms off the coast of Australia? There's only very few states that currently allow us to do that, even though there is a lot of people who are wanting to grow seaweed for various reasons. And also there's some issues with, do we recognise these people as farmers, or are they, what are they that they're actually doing? There's also big issues with people don't actually know what algae is. So a lot of people might have heard what seaweed farms are and stuff. There's quite a lot of movement, particularly in places like Canada, Southeast Asia, there are seaweed farms. But for microalgae farms, there's probably only a couple of handfuls of people who actually have large-scale algae farms in Australia, and people don't know that they exist or what their function is or all that sort of thing.
And
so
do they sort of have an impression of, you're interested in science communication as well, and there's a challenge here. People think of algae as slime and blue-green algae and pollution in the waterways, and, there's that association, is there?
Oh, yeah, totally. I mean, when I had to explain to my parents what I did for a living, the look of confusion on their face, because the only interaction that they'd had with microalgae is my dad putting chlorine into the pool. And that's a really hard barrier to overcome with people and say, this stuff is really valuable. This stuff could be putting, fuel in planes. It could be making the next clothing. It could be capturing carbon. People don't, it's trying to explain, if you'd never heard of mushrooms before, trying to think about explaining what a mushroom is and all the different things you can do with mushrooms to someone who's never heard of mushrooms before. It's that kind of thing that we're starting here. Australia has a huge potential. We've got so many species that we can exploit for so many different things. There's so much land that we can grow these things on. And, the biggest thing that algae needs to grow is sunlight. We got a lot of sunlight, but there's a couple of barriers that we need to overcome to start making this industry more competitive and actually getting more people into it and getting it moving.
So you've listed some of the barriers there. What would be the top three that you can think of?
Top three, I think it's kind of this legislation level thing. I think there's a lack of public awareness, and I think, it's really hard when you are starting an industry somewhere new. There's a lot of people who are doing really groundbreaking work. Like, Pia's been around doing amazing work for a long time, but a lot of people are disconnected. And so it's really hard for people to go out there on their own and really start these businesses and start these new innovations. And when you don't have government support and there's things like big financial barriers in place, it can be really hard to get going. But I think once we kind of break that damn wall, there'll be an absolute ocean of opportunities out there, for this stuff to make a big impact.
So you're involved in an Algae Accelerator program, is that right?
Yes.
And at the Climate Change Cluster Research Institute at UTS. So what range, we've heard of a couple of opportunities here, but what other opportunities are there for algae, as you see it?
In terms of what types of things it can do?
Products, opportunities, environmental solutions.
Yeah, I have a box in my office at work that I have a whole bunch of samples from different businesses that we work with, but also what the researchers are coming out of the lab on a almost daily basis of the new things that they've made. So just to kind of give you a bit of a dot point list of the types of products that we're seeing coming out, we're seeing everything from tiles, bricks, plaster. We're obviously seeing a lot of plastics. There's a lot of companies in Australia who are obviously making compostable, biodegradable, algae-based plastics, because plastic are made from fossil fuels and the building block of fossil fuels is algae, so just cut out the middleman. Where we have made new fibres made entirely out of seaweed and microalgae, which have turned into fabrics, which are an alternative to things like cotton. And we've also seen a whole range of different foods, supplements, alternate proteins. The really interesting thing too is also pigments. So things like pigments that you put into your clothing, which are traditionally quite there's some pretty nasty chemicals that go into dyeing your clothing, but also things like actually printing paper. So there's a company over in the US that actually make ink that print onto paper, and they make that ink out of an algae that they grow in wastewater plants as well.
I'm interested in the work of Sam Elsom, who was a fashion designer and is now feeding seaweed-based products working with cattle farmers to feed them seaweed-based products to reduce their methane emissions.
Yeah, Asparagopsis is a really interesting space. I think we've seen when people... It's Australian innovation for people that aren't aware. Some scientists in CSIRO about 10 or 15 years ago found a seaweed called Asparagopsis. It's a red seaweed. You can actually find it off Bondi. That when you feed it to cattle, it reduces their methane emissions by up to 90%.
Amazing.
It's not farts, it's burps. Cows burp
That's
methane.
true. Yes, sheep do too.
I think what the kind of, this wave of new knowledge, but because it's been coming out of Australia too, I think it's been a great kind of mechanism to introduce more people to seaweed and what seaweed can do. And there's a whole bunch of work coming off the back of that to understand what other things can we do with this seaweed? How can we cultivate it at scale? How can we allow more people to cultivate seaweed? So I think it's been a really great tool to kind of see a lot of people becoming more interested in the capability of things like seaweeds and microalgae.
This is like an algae and seaweed speed dating session today. And so I'm going to ask my final question of Michael and Pia. Michael, rounding back to you, Michael Askew at AlgaeCo. How do you see the challenges ahead for the industry in Australia as you launch in Australia too? You've been working in India.
Yeah.
What would you like to see?
I'd say Australia, I have a biological innovation business. We don't just have algae, we have other treatment products. We are behind 10, 15 years in regulation, but I feel as though we've just hit it at the right time. So I've been working in impact my whole life, and I worked out pretty quickly that if you couldn't make something work from an economic point of view, a business work, it'll have impact for 2 years and fall over. And at AlgaeCo, we're not going to do that. We're going to be around for hundreds of years and be a generational business. So you have to be profitable. So some of the people that have come into the industry before, they don't really understand. They're not microbiologists, they're green entrepreneurs, and of course the business falls over. Now in Australia, what we're seeing, scientists who know the industry well, industrial scientists, microbiologists coming together because we're talking about big infrastructure projects. And Australia's is ready now, and we're seeing a number of businesses really take off.
Interesting. Pia, last word to you on how you see the challenges ahead, because you are very mindful of the hype and unsubstantiated claims. The wellness sector is full of unsubstantiated claims, and they're ready to pounce on any product that's available to them and get it out there to make squillions. You don't want to see that happen.
No, we can fall over if we're built on hype, because hype doesn't have anything underneath it. So we really need to be aware of that. But I think the biggest challenge and opportunity, though, is with the people. We can't look to the governments to make that decision. We can't look to big companies to change their big systems. It's actually up to all of you and people out there to just make the choice of buying and know that you have that choice on your plate, on your paper or ink coming up, that you actually actively seek products made in sustainable ways from algae. And also, algae can be damaging if you don't grow it correctly either. And so the MSC has got certifications as well for where you can buy your algae and which ones are MSC, the Marine Stewardship Council.
Marine Stewardship Council.
And others. So learn to trust and understand sustainable sources of algae. I mean, seaweed farming in Indonesia, unfortunately, is one of the biggest polluters of styrofoam in the oceans. And it's a simple solution, but we have to be aware of it and we have to ask for change on that front.
Why styrofoam?
To float the seaweed lines.
Yeah,
that's
right.
all. It's what they've got. So they use styrofoam.
Wow, and that's in the ocean. Any industry can do harm, can't it? If you overexploit an environment within which you're kind of maintaining that industry. Really interesting. Thank you so much for being at the Ocean Lovers Festival. And I'm sure each of the speakers will be available to have a chat outside afterwards if you'd like to continue the conversation. Please thank Michael Askew, Pia Winberg and Alex Thomson.
Thanks for tuning in. We hope you enjoyed this episode of Ocean Ideas. Please make sure to share it with your networks and help us in our mission to turn ripples of action into waves of change for our blue planet.